This video is on Unit 4 on polynomial functions, Chapter 8, Introduction to Polynomial Functions, Lesson number 1 on monomials and polynomials. In our notes here, it introduces you to the first vocabulary word, a monomial. A monomial is a number, variable, or a product of numbers and variables. And I've got 3 different examples here. So if it's just a number, like the number 4, that is a monomial. It can be a variable, like 7x, or just plain old x. Or it can be a product of numbers and variables, like the 7x or the 3x squared. All of those are examples of monomials. The one thing that's missing is pluses and minuses. Once we start adding pluses and minuses, you end up with binomials and trinomials and things like that, which we're going to talk more about here in just a second. Use the exponent rules to simplify monomial expressions. Now, we talked about these exponent rules back in Chapter 7. But this is where it's laid out really nice and pretty for you. So the first rule is your product rule. And in algebraic terms, a to the m times a to the n is equal to a to the m plus n. So for example, if I have x squared times x to the 7th power, that answer is x to the 2 plus 7 is 9. So the answer there is x to the 9th. The next rule is called your power rule. A to the m is being raised to another power, which is the nth power. And to find that answer, you're going to multiply those exponents. So you get a to the m times n. So for example, if I have x squared and I want to raise that to the 7th power, it's going to be x to the 14th power because, again, you multiply those exponents. For your quotient rule, we're dividing, and when we divide, exponents are going to subtract. A to the m divided by a to the n is a to the m minus n. So if I have x to the 7th divided by x squared, 7 minus 2 is 5. So I would end up with x to the 5th power there. For negative exponents, we also talked about negative exponents and the fact that they make fractions. You have to change its position in the fraction. So if I have a to the negative m, it's going to change to 1 over a to the m. That negative exponent turns positive once you move that base and that exponent to the opposite part of the fraction. So if I have x to the negative 2 power, it's going to be 1 over x to the positive 2. Again, once you move it to the opposite part of the fraction, that negative exponent becomes positive. And then you've got your 0 exponent rule. A to the 0 power is always 1. If you have 0 to the 0 power, it is undefined. So for example, if I had 7x squared raised to the 0 power, that's going to be 1 as long as x does not equal 0. So to recap, for your product rule, you add exponents. For your power rule, you multiply exponents. Quotient rule, we're going to subtract exponents. For your negative exponents, you're going to move the base to the opposite part of the fraction. And then for your 0 exponent rule, it's just always equal to 1. I do want to add 1 here in the margin. When we are adding or subtracting, exponents don't change. For example, if you have x to the 2nd plus 3x to the 2nd, you're going to get 4x to the 2nd. You just add your coefficients and leave the exponents alone. So let's look at some of these examples. In example number 1, I've got 5x squared times negative 7x to the 6th. So let me back up for just 2 seconds. These rules apply to exponents and exponents only. So on example number 1, the 5 and the negative 7 are coefficients, so they follow the rule. It says to multiply, I'm going to multiply and get negative 35x to the add 2 plus 6 is 8. And your answer there is negative 35x to the 8th power. On number 2, you have negative 2a to the 3rd b is being raised to the 2nd power times 8ab to the 9th. So we're going to take this one step at a time, following order of operations. I'm going to square that parentheses. And you have to distribute that exponent to each part. So negative 2 squared is going to be 4. A to the 3rd squared is going to be a to the 3 times 2 is 6. And b to the 1 times 2 is 2. And we're going to multiply that times the 8ab to the 9th. So now the operation says to multiply, we're going to add exponents. We are still going to multiply the 4 times the 8 to get 32. A to the 6 plus 1 is 7. B to the 2 plus 9 is 11. And the answer there is 32. A to the 7th, B to the 11th. All right, let's jump down to number 3. 54m to the 6th n to the 4th divided by 3m squared n minus 10m to the 4th n to the 3rd. So we need to take care of our fraction first. Now, because it's a fraction, it is division, we need to subtract those exponents. But again, 54 and 3 are not exponents. We're going to go ahead and divide. 54 divided by 3 is going to be 18. And then I'm going to subtract. 6 minus 2 is 4. And 4 minus 1 is 3. Minus 10m to the 4th and to the 3rd. Now, when we talk about adding and subtracting, we've got subtracting here. I said that you're going to combine the like terms and don't change exponents. So the only reason we are actually able to subtract these two terms is because they both have an m to the 4th and to the 3rd, and 18 minus 10 is an 8. But your exponents, your variables, and the exponents do not change. So we end up with 8m to the 4th and to the 3rd. I want to look at number 4. 2k to the 4th times 10k to the negative 7th. We're going to go ahead and multiply the 2 times the 10, which is 20, and then add our exponents. So k to the 4 plus negative 7 is a negative 3. Now, negative exponents in your answer are not okay, so we need to fix that. The negative 3 is only attached to the k, however. That negative 3 is not attached to the 20. So the only part of that that's going to move is just the k. The 20 will actually stay in the numerator. Had that been parentheses, that would have been a little bit different. But your answer there is 20 divided by k to the 3rd. I want to jump to number 6. I've got 14w to the 12th divided by 7w to the 3rd. And that's being raised to the negative 1 power. There's lots of different ways we can start this. I am going to take care of the negative exponent first. So to change this to a positive 1, we're going to just flip that fraction. Now the outside exponent is a positive 1, which I'm not going to put. And then from here, we're going to reduce the 7 and the 14, which would be 1/2. Now, I want to talk to you about these w's. So what I've been doing before is we've said to subtract. 3 minus 12 would be a w to the negative 9th power. But negative exponents are not allowed. So we would have to move that w to the negative 9. Now, the 2 is not going anywhere. The 2 is not going anywhere. It's not like we're flipping the whole entire fraction. We're only flipping that negative exponent and what it's attached to. So that goes down to the bottom. So we have 1 over 2w to the 9th. But I do want to say to you a little shortcut here. If you'll notice that there are more w's in the denominator than there are in the numerator. So the shortcut here, the little trick, is that tells me that my w's are going to end up in the bottom, and I would subtract backwards and say 12 minus 3 gives me that positive 9, but I know it's going to be in the bottom. Let me show you what I'm talking about on number 7. So we're going to go ahead and reduce the 15 and the 24. What number goes into 15 that also goes into 24? That's going to be a 3. So that's going to change to 5 over 8. So looking at my x's, just the x's, I have an x to the 10th in the top and an x to the 12th in the denominator. 12 is bigger than 10, so I know my x's are going to end up in the bottom, and I'm going to subtract that way. 12 minus 10 is 2. I'm still subtracting. I'm still following the rule. I'm just taking a bit of a shortcut and eliminating that whole negative exponent experience. With your y's, you have a y to the 4th in the top and a y to the 3rd in the denominator. 4 is bigger than 3. So my y is going to end up in the numerator, and 4 minus 3 is 1, which I don't need. So my answer is 5y over 8x squared. Looking at the next page, number 9 says, give an example of 2 monomials with a quotient of negative 3n squared over n. So 2 monomials with a quotient of negative 3n squared over n. So basically, we're trying to figure out what fraction is going to give me a result of negative 3n squared over n. So something that's going to reduce to a negative 3, there's lots of answers here. You could come up with your own. I'm going to say negative 36 and a 12. Negative 36 divided by 12 is negative 3. And then for my m's, I just need to make sure that if I'm going to end up with an m in the bottom, then my exponents need to have one more in the bottom than it does in the top. So let's say if I had 4 in the top, then I would need 5 in the bottom, so that I would end up with 1 in the bottom. N squared needs to be in the top. So again, I need more n's in the top. So let's say I had n to the 7th. Then that means I would need n to the 5th in the bottom, because 7 minus 5 is the 2. All right, let's keep going. For polynomials, a polynomial is the sum or difference of many monomials. So this is where the pluses and minuses come in. The highest exponent of a polynomial is called the degree. And then for standard form, you always want to write the exponents in descending order. Descending means decreasing. So we're going to look at example number 10. Write the polynomial below in standard form. I have negative k to the 5th minus 1 plus 8k minus 3k cubed plus 1/4 k squared. Looking at just the exponents, 5 is the biggest, so that's going to go first. I don't have a k to the 4th, then k to the 3rd would go next, so minus 3k to the 3rd. And then I need a k squared. That's a positive 1/4 k squared. And then the k plus 8k. And then the constant, which is minus 1. So that is descending order. And also, as an added bonus, your degree here, if I asked you to identify the degree on that would be 5, because that is the largest exponent in that polynomial. On 11 and 12, I feel like these are bad questions. In my opinion, we cannot put the polynomials in order in any kind of standard form because there are too many variables. The person who created this, I disagree with their thought process behind number 11 and number 12. So just FYI, if there's more than one variable, order doesn't matter. So classifying polynomials. Polynomials are classified by their degree, which is their highest exponent, and the number of terms. So you want to use the charts to the left to classify each polynomial. So let's talk about these charts to the left. There's two ways to classify a polynomial. We first look at, well, one of the things that we look at is the degree of the polynomial. And again, that's the highest exponent. So you've got, if the highest exponent is a 0, meaning there are no x's, then it is a constant. If the highest exponent is a 1, we call that linear. If it's a 2, that's quadratic. If it's a 3, cubic. 4, quartic. 5 is quintic. So again, constant is just a number, like 5. Linear would be just a plain x, like maybe 5x. Quadratic, you might have 5x squared. For cubic, you might have 5x cubed. Sticking in my theme with the 5x to the 4th. And then for quintic, 5x to the 5th. It's all about those exponents. Constant is the one that is most commonly missed among students. Again, there is no x. For the number of terms, if it only has one term, it is a monomial. If it has 2 terms, it's a binomial. 3 terms is a trinomial. Anything more than that, 4 and more, we just call it a polynomial. So on this section here, it asks you to classify. So looking at number 13, the largest exponent is a 1. So this is a linear. And there are 2 terms, so it's a binomial. And that's how we do that. And I don't care which word you list first. That does not matter to me. On number 14, the highest exponent is a 5. So that would be quintic. And there is 1, 2, 3 terms, so this is a trinomial. On number 15, there is no x. This is just your constant. And it is just a monomial because there's only 1 term. So that's how that's all done. We're going to move on to the next page in the notes. So adding and subtracting polynomials, you want to combine your like terms, watch out for subtraction problems, and then write your answers in standard form. So looking at example number 1 here, we've got 3x squared plus 11x plus 4 plus negative 5x plus x squared plus 13, minus 13. We have been doing this the whole entire semester so far. So again, you're just looking for your like terms, and I always start with the largest exponent. So 3x squared plus x squared is going to be 4x squared. And then my x is 11x plus the negative 5x is a positive 6x. And then 4 plus the negative 13 is going to be the negative 9. And there's your answer on that first example in this set. For subtraction, just like I've always done, I would encourage you to distribute that negative 1 before you combine your like terms. So the first set are not going to change. And then negative 1 times 2k squared is a negative 2k squared. Negative 1 times a 2k is a negative 2k. Negative 1 times 17 is a negative 17. And then again, go through and combine your like terms. The largest exponent is 3. There's only 1 of them, so I'm just going to bring down that 5k cubed. For my squares, I have a negative 2k squared minus another 2k squared, which gives me negative 4k squared. Then your k's, 2k minus k is going to cancel out. They're going to subtract out, and then the minus 17. So your answer here is 5k to the third minus 4k squared minus 17. On number 5, it says to subtract negative 10ab plus 7a squared minus b from 8b squared plus ab minus 2a squared. So the reason why I'm talking to you about this is because of the wordage and making sure that you guys do know that because you're subtracting this parentheses, this first one, from 8b squared plus ab minus 2a squared, the 8b squared goes first. So with subtraction, order does matter. Make sure that you list them in the correct order. And then, of course, make sure that you distribute that negative 1. So I have 8b squared plus ab minus 2a squared plus 10ab minus 7a squared plus b squared. And then, of course, I'm going to combine my like terms. Now, this is a perfect example of one where I do not count off if your order does not match my order, because there are multiple variables here. Order doesn't matter. I am going to start with the b squares. 8b squared plus 1b squared is 9b squared. And then I'll do my ab's. 1ab plus 10ab is a positive 11ab. And then the a squares, negative 2a squared minus 7a squared, will be a negative 9a squared. So there's the answer for that one. For multiplying polynomials, the steps are 1, distribute or FOIL. Number 2, combine like terms. Thirdly, write your answers in standard form. I want to start with example number 7. We're going to FOIL the first two together, and then we can distribute that negative 2x. So starting with the FOIL, 2x times 4 is 8x. 2x times negative 9x would be negative 18x squared. 1 times 4 is 4. And then 1 times negative 9x is negative 9x. And then I'm going to distribute the negative 2x. So I get negative 6x squared and a negative 22x. And then lastly, I'm going to combine those like terms, starting with the largest exponent. Negative 18x squared minus 6x squared is negative 24x squared. And then for my x's, there are 3 of them. So 8 minus 9 minus 22x gives me a negative 23x. And then your constant is last, and I get the plus 4 for that answer. The other one that I want to look at in this section is number 9. So 2c plus 5d being raised to the third power. So this means 2c plus 5d is being multiplied 3 times. Now, you cannot multiply all 3 of those at the same time. What you have to do here is just pick 2, do those first, and then take that result and multiply that times the next one. So I'm going to just start with these first 2. Foiling. 2c times 2c is 4c squared. 2c times 5d is a positive 10cd. And then 5d times 2c is another 10cd. And then 5d times 5d is a positive 25d squared. I'm going to combine those like terms. Now we can multiply that times the 2c plus 5d, the last one. So this is a trinomial times a binomial. So 4c squared times 2c is 8c cubed. 4c squared times 5d is a 20c squared d. This problem is about to get really confusing. Now the 20cd times 2c is a positive 40c squared d. And then the 20cd times the 5d is a positive 100 cd squared. And then lastly, our 25d squared times both of those terms is going to give us a positive 50 CD squared. And then the last one is 25D squared times 5D is going to give us 125D to the third. And then we've got to try to combine our like terms. So these two are the same, and these two are the same terms. So my final answer is 8C cubed plus 60C squared D plus 150CD squared plus the 125D cubed. So I feel like the variables made that problem a lot worse than what it is. Going backwards to number 8. Again, you can't multiply more than two things at a time. So on number 8, I would just kind of split this down the middle and multiply the left two together, multiply the right two together, and then get those two answers and then multiply that. So for example, the left one here is just going to be negative 3a minus 15. Easy. So then we're going to FOIL the other two. So a squared plus 8a minus 2a minus 16 gives me a squared plus 6a minus 16. And then that gets multiplied by the negative 3a minus 15. So it's not really as bad as you think. Number 9 was just horrible because of all of the different variables. So negative 3a times a squared would be negative 3a to the third. Negative 3a times 6a would be negative 18a squared. Negative 3a times negative 16 is going to be a positive 48a. And now the negative 15 times a squared is negative 15a squared. Negative 15 times 6 is going to be a negative 90a. And then negative 15 times negative 16 is going to give me a positive 240. Combining my like terms, I end up with negative 3a cubed minus 33a squared, because that's your negative 18 combined with your negative 15. For your a's, you got a positive 48 and a negative 90, which gives you a negative 42a and then the 240. So that's your final answer on that one. Moving on, up at the top, we are not going to work these out. A trinomial times another trinomial is just a lot of distributive property. You would multiply the 3m squared by everything in the other parentheses, the negative 4m, as well as the 1. But that's all distributive. We've been working on this all semester, so you should be good. The last thing I want to talk to you about in this video is dividing polynomials when we are dividing by just a monomial. Now, when we divide by a polynomial, that's a whole different story. That's another lesson. But when we're taking a polynomial and dividing by a monomial, it's just basic, simple division. So you're going to divide each term in the numerator by the monomial in the denominator, and then write your answer in standard form. Rewrite all terms with negative exponents. So if it has a negative exponent, you have to fix it. So on number 13, basically what's happening here is that 9m to the third is going to be divided by the 3m. And the negative 24m squared is going to get divided by the 3m. 9 divided by 3 is 3. Subtract your exponents and you get m squared. Minus 24 divided by 3 is 8. And then m squared divided by m. Subtract those exponents and you get 8m. And that is in standard form. So number 14... Again, you're taking the 20x to the third minus 4x squared minus 8x, and we're dividing every single term by 4x. For those of you that need the visual, again, you're just dividing every term in the top by the 4x. So 20x to the third divided by 4x is going to give me 5x squared because, again, you are subtracting those exponents. 4 divided by 4 is 1. And then for my exponents, 2 minus 1 is 1. And then negative 8 divided by 4 is negative 2. And those x's are going to cancel, and that answer is already in standard form. I do want to talk quickly about number 15. So it says 14a to the fourth b to the third minus 20a squared b squared plus 2ab is being multiplied by 2ab to the negative 1 power. Well, 2ab to the negative 1 power is the same thing as 1 over 2ab to the positive 1 power. So basically what's happening here is you're taking that trinomial and you're dividing by the 2ab. So 14 divided by 2 is 7. Subtract those exponents. 4 minus the 1 is a to the third. 3 minus 1 is b squared. Next term. Negative 20 divided by 2 is negative 10. Subtract your exponents. 2 minus 1 is 1a. And then for b squared minus the b to the 1 is going to be just a b. Plus 2ab divided by 2ab is just plain 1. Those variables are going to go away. And there's the answer for number 15. So that is dividing by a monomial. FYI, you can end up with fractions on these. If we'll look quickly at number 18, 40m to the third, n to the fourth, minus 24m squared, n to the seventh is being divided by 8m squared, n to the fifth. So 40 divided by 8 is 5. And then for your exponents on your m, 3 minus 2 is 1. And then if you look at your n's, there are 5 n's in the denominator and only 4 n's in the top, which means your n's are going to end up in the denominator. 5 minus 4 is 1. So that's the first term. Minus 24 divided by 8 is 3. M squares are going to cancel. For my n's, I have 7 in the top and 5 in the bottom. So the n is in the top. 7 minus 5 is 2. So there is no denominator on that. And there's your answer on number 18. So those are your notes for Unit 4, Chapter 8, Lesson number 1.